In this video, we're going to look at a new kind of probability, and that is a conditional probability. And in a conditional probability, only a portion of the sample space is examined. We have some condition that narrows down exactly what we're looking at. And these aren't and probabilities, and these aren't or probabilities. You're not going to see the word and you're not going to see the word or in a conditional probability. Given is sometimes, but not always, a key word that indicates you have a conditional probability. To clarify this a little bit better, I'm going to go back to this two-way table that we've seen several times already and show you a couple of conditional probabilities that narrow down the sample space. A asks, based off of this two-way table, what is the probability that a selected person had a cat and was from the South? So I'm looking at the person having a cat, being from the South. So those are my two categories listed, but it's an and probability. An and means overlap. So where do these two overlap? Here is cat column. Here is the South row. They overlap at 115. So it'll be 115 out of 1,000. As a decimal, I could take this 115 divided by 1,000, and I get 0.115 or 11.5%. A here is not conditional. However, B is a conditional probability. It says, what is the probability that a selected person with a cat was from the South? If you read carefully, note that there's no and there's no or at all in part B. So this is not an and probability. I'm not looking at the overlap. This is not an or probability. I'm not looking for the total. I'm not going to add. But it's conditional. I'm given the selected person had a cat. They were with a cat. So that tells me that I'm only looking at these people, the selected person with a cat. I'm only looking at these 250. Now, out of these 250, I want to know how many people were from the South. Well, that would be 115. Just to get my probability, take 115, divide it by 250, and I'll get 0.46 or 46%. So 46% of people with the cats were from the South. C is a very similar question. There's a slight difference, and our answer is slightly different. C says, what is the probability that a selected person from the South had a cat? Note there's no and, there's no or in the wording. But I'm looking at two categories, being from the South and having a cat. I'm not going to look at their overlap because it's not an and probability. I'm not going to add them together, but I'm going to use the condition. I'm looking at the probability that the selected person from the South, so I know that about the person. The person was from the South. They weren't from the Northeast, they weren't from the Midwest, they weren't from the West, they were from the South. So I'm only looking at these 450 people. I'm not looking at all 1,000, not the entire sample space. I'm only looking at those 450. Out of those 450 from the South, how many had a cat? Well, 115 did. Take that 115, divide it by my 450, and I get 0.2556 if I round to 4 places, which is 25.56%. As far as notation goes, the probability of A given B, the probability of something occurring given that your sample space is narrowed down to B, can be written as this, capital P for probability, in parentheses, A, this vertical line means given, A given B. B and C from above indicate that the probability of A given B is not equal to the probability of B given A. This was the probability a person was from the South given they had a cat. I knew the person had a cat. They were with a cat from part B. Part C is probably a person had a cat given they were from the South. So even though it's the same two categories, when we switch these, we got different results. This was 46% in part B, and this was about 26% in part C. Conditional probabilities can also be calculated as the probability of A and B over the probability of B. However, we'll primarily use two-way tables for these probabilities, and you can calculate them exactly how we just did in this example.